Good morning, good afternoon, good evening. Today we'll be making the snake filled text. This node setup by itself is not a text effect per se, but it is a unique way to fill a text curve. I won't be going over making an animation in this video, but this can be used to make CNC engraving animation, or create some cool looking custom fonts for your own use. I think it's a node group worth playing around with. Alright, let's start. As soon as we enter Blender, let's hop right into Geometry Nodes Layout. A to select all, X to delete. Shift A, add a new mesh plane. Using numpad 7 and 5, go into top orthographic view. Click on New to create a new map. Delete group input, and replace it with string input. Let's start with one letter, a capital T. Pass it through strings to curve and output. And we got the letter T. The snake fill text is a kind of cool way to mesh fill the text. Just imagine curves filling up the interior of the text like so. Alright, let's get into it. So first, I want to fill this text with a bunch of horizontal splines. Let's realize a curve instance right after strings to curve. Then, connect a bounding box to measure the dimensions. If you're using Blender version 4.5 or above, make sure to turn off this Use Radius option. We'll at first ignore the text shape and align splines along this bounding box. Now, from bounding box min, pull out a curve line and connect to start. We want to place the end position on bounding box bottom right corner, so pull out a separate XYZ from max and min. Then combine max x, min y, and min z as a vector and connect to end. We should now have a curved line along the bottom bounding box edge. Next, we'll duplicate lines upwards in uniform spacing. So let's define the line spacing using a value node. I'll set this to 0.01 meter for now. Get the dimension of bounding box by vector mass subtracting min from max. Then vector mass divide the result with spacing value. Separate XYZ and add 1 to y to determine the amount of lines required. Add a duplicate element after a curved line and change the domain to spline. Connect the add result to amount. We can confirm that we have multiple splines by looking at the spreadsheet. Lastly, let's offset these splines upwards. Add a set position node and connect combine XYZ to offset. Multiply the duplicate index with spacing value to get the each offset amount. Connect the result to y to have the splines placed in uniform distance. The spline array should now be roughly the same size as the bounding box. We now want to cut out the letter T from these splines. But before we do that, I want to store this duplicate index so we can use it later in the map. Insert a store named attribute, set it to integer, spline, and name it didx. Store the duplicate index value as attribute. Let's now cut out the text using raycast. Prepare the target by curve filling the realized text. I'll just use Ngon fill for this. We can't make a cutout in spline form, so we'll convert the spline array to edges first. But before we do that, let's resample with 0.01 lengths, so we have more points to play with. Then convert splines to edges with curve to mesh. Then convert edges back again to spline with mesh to curve. It might make no sense, but if we raycast from fill curve and connect the is_hit result to mesh to curve selection, we end up with this cutout. It might be less accurate than Boolean, but I believe it's a faster way to achieve this result. Next step is, we'll be connecting the splines going back and forth. Kinda like this. To do so, we need to set the direction of the spline so they alternate. The bottom goes right, the next one goes left, and so on. Let's set that up. First, connect the reverse curve. Then we'll use the didx we stored earlier. Get the named attribute didx and connect to integer math modulo. Mod it by 2 and directly connect to selection. It does not look any different, but they should now be alternating. Next, we really have no use for this much verts, since we're dealing with straight lines. We'll leave the endpoints and delete the rest. Add a separate geometry and connect endpoint selection. The point count should decrease to 138, which is just a number of endpoints. To finish off the prep, we'll store the starting point indicator as an attribute. Add a store named attribute, set it to boolean, point, and call it is_point_st. Duplicate the endpoint selection and only store the starting point as value. We're done with the prep, so I'll explain a little further in detail. So for each ending of a line, let's call this point A, we want to find the next line starting point, point B. Then add another line in between that bridge them together. It's going to be in multiple steps of sampling, so it might be confusing, but please try to follow along. So we cannot connect lines in curve domain, so let's first curve to mesh and convert to edges. Attributes are inherited even after conversion, so we'll be using this to our advantage. Add a for each element node and set domain to edge, then reconnect. Currently all edges are outputted, but we can isolate single edge by connecting element socket to viewer. Let's start by extracting point A. Connect a separate geometry to element, and from selection, boolean not, then named attribute. We'll get the is_point_start we just stored. Viewing the result, it is hard to see, but point A should be the only point that shows up. Next, for point B, since element socket only contains the first edge, we must use the original mesh before for each element. Connect to separate geometry. We want the starting point, so let's filter with is_point_start. Now, starting points for all edges should be extracted. Within these points, we want to filter down to the edge right above point A. To do so, we can use a didx, since if point A didx is 0, we know we want the didx of 1 for B. From separate geometry on top, connect the sample index. Set it to integer, point. Then sample named attribute didx to get the didx of point A. Add 1 to the result and compare equal with connect another separate geometry from the bottom separate geometry, then use the compare result as selection. Now the point B should be extracted. Let me just remove the annotation so we can see. There is a hidden issue though. We can't see this since we're using the letter T, but if we change the original text to R, it's more obvious. In the viewer, we now have 2 points that fits the filter condition. So there is a possibility that we end up with multiple candidates with just a DIDX condition. In that case, we want the nearest point from A chosen as point B. Branch out a sample index from point A separate geometry. Set this to vector, point, then connect position to value. From the bottom point B separate geometry, connect the sample nearest and use the point A position as sample position. We now got the closest point index out of multiple candidates. Grab a sample index out of the bottom separate geometry, set it to vector, point, then connect sample nearest result to index, and position to value. Now we have the position for both A and B. Just to clarify, the top sample result is of point A and the bottom is of point B. Now, add a mesh line to bridge these 2 points. Set mode to endpoint and count to 2. Then connect point A position to start and point B position to end location. It's been a long process, but now we have this vertical edge. Add a join geometry to the element line and join the vertical edge we just made. Now, the final output out of for each element should now have all edges connected. Here is how it looks now. We have these long diagonal lines that are not visually appealing. Feels very unnecessary, so let's get rid of them. However, we shouldn't be deleting all diagonal lines, so we'll make a cutoff condition. After this mesh line, insert a switch node. Connect the mesh line result to false. Then, we'll take the vector mass distance between point A and point B. Compare the distance result with greater than of 0.05 and plug it into switch to delete the long lines. Now, we have clean snake fill result. Lastly, we'll connect the resulting edges with merge by distance and convert with mesh to curve. We should end up with 3 splines. R cannot be represented with single line, so this result is okay. We need faces in order to render, so we'll curve to mesh to convert back to mesh. Use curve line for profile. Set -0.5 to 0.5 for X. Use the scale to adjust the face width. 0.005 should be a good value. Let me zoom in for more detail. We have these uneven lines that are not that great. To clean them up, let's add a resample after mesh to curve and add more points. Then, insert a set spline type and convert them to NURBS for rounded corners. For the last step, I'll group nodes up for ease of use, starting from this realize and ending at this mesh to curve node. Select the nodes in range and Ctrl G to group them up. I'll turn some values into arguments to control them externally. Open up the side panel with N, then turn this value node into group input. Change the type back to float and call it spacing. Next, this resample after DIDX store. Call it H resolution. Last one is this B for greater than compare. Call it cutoff distance. A little node cleanup. Tab out and call this node group snake fill text. Let's set the spacing back to 0.01. And a little more cleanup. Alright, let's play with some input values. Changing spacing will allow you to control how many turns we'll have. 0.04 ends up with this very spaced out result. I like how it's kind of futuristic cyberpunk font. H resolution controls how close the result follows the original text curve. Large amount results in a blockier mesh. Smaller value will make the fill follow the original text curve more accurately. Cutoff should be adjusted accordingly. We'll confirm with multiple letters now. Well, it looks like it's working. So let's go over the node map. Not much interesting in the top layer. Content of snake fill text. The map is kind of elongated, but here it is. Let's look at it from the left. In the left portion, we are making an array of horizontal splines. Then, some preparations in the middle. And we are connecting the splines in for each element. There's a lot of sampling, so it might be a bit complicated. Alright, that's it for this one. I'm not doing materials or animation for this, but this fill can be used as guides to make engraving animations, or make cool custom fonts, so do play around with it. I might release videos using this node group as a base in the future as well. Thanks for watching, and see you in the next one.